Hello and welcome to my YouTube channel Electrical Hub. Here we are going to discuss about the efficiency of compressor. This is the part 2 of the efficiency of compressor. The part 1 is already discussed, so you can go and check the video. I will also provide the link in the description box. I would like to request you to kindly like, share, and subscribe for more information about electrical engineering. We are going to discuss here about the air dryer because air dryer is one of the most important part of the air compressor. Then Dalton's law of gas pressure and dew point. Types of the air dryer, how to calculate the diameter of the pipe required for conveying the compressed air and the free air delivered. Why the air dryer is required? About 60 to 75% of the moisture in the compressed air is removed after cooler. But the remaining amount of the moisture can cause a huge damage. The line generally used for conveying of the compressed air are of MS. So that means iron. So there is a huge chance of corrosion if there is a moisture. So when it will corrode, it will also form the rust, and that rust will go into the equipment, causing the failure of the equipment. Secondly, when the moisture contained air will go into the pneumatic equipment, it will cause the failure of the operation of pneumatic equipment. What is the Dalton's law of air pressure and dew point? See, with the increased pressure, there will be increase in the pressure of the water vapor, and there will also be an increase in the dew point temperature. For example, here, if the pressure of the air is 1013 millibar, pressure of water vapor is 2.8, and dew point is minus 10 degrees centigrade. If the pressure of the air is increased, then automatically the pressure of the water vapor will also increase in the same proportion of the pressure of the air, and the dew point will reduce up to minus increase up to minus 1 degree centigrade. So what are the types of the air dryer? There are generally two types of the air dryer used in the industry. One is the refrigerant type, and the second is the adsorption type. Third is also used, that's membrane type, but it is not used in most of the industries. There are three types of adsorption type dryer. One is the blower reactivated type, second, heatless purge type, and third is the heat of compression type. Refrigerant type. It is a very economical type of dryer. It is a purely mechanical process. Refrigerant type by the name it means that there will be a refrigerator, means there will be cooling. Here the dew point is reduced by chilling. Hence a secondary heat exchanger is introduced where outgoing air pre-cools the incoming air. As you can see in the drawing, the achievable dew point is up to minus 20 degrees centigrade. Here, any particles larger than 3 micron are completely separated, and the pressure drop of the air is also very less, that is zero point 0.2 bar only. While the refrigerant dryer is purely a mechanical process, the adsorption drying is purely a physical process. It is done by unbalanced molecular attraction. It has a large open porous structure and a larger inner surface. The most commonly used adsorption material are aluminum and silica gel. The moisture, the moisture stays on the inner and the outer surface without any chemical reaction. Here is an drawing of adsorption type dryer. So as we have seen in the adsorption type dryer is that there are two chambers. So one chamber is always in use and the other is for regenerate is under regeneration means it goes on for cleaning of the moisture contained in it. So the adsorption dryer is divided into three types according to the type of regeneration. So first is the blower reactivated type. In the what happens in the blower reactivated type? A blower is used and a heater is used. This is used for a capacity of higher than 250 CFM. So what can be the losses here? One is the heater are used. So the electrical consumption will be higher. Secondary, as we have seen in this diagram, that a purge line is used. So that is means for the cleaning of the second chamber, a part of the compressed air is used. That is a loss of 2% of the compressed air. Now, the second one is the heatless purge type. It is used for a lower capacity, that is less than 250 CFM. Here you can see that no blower, neither a heater is used. Only the dry compressed air is used for purging. And hence here the purging loss is higher, that is approximately 12 to 16%. The purging here itself is used for regeneration or cleaning of the second chamber. Heat of compression type. It is the most convenient or economical dryer. It is available from 400 to 5000 CFM. Why it is economical? Because here there is no electricity loss because no heater is required, no purging loss because no compressed air is used for purging. So, how it is regenerated? Here also the compressed air is used, but it is used before and after cooler, and then it goes to the dryer. Means after the air is compressed, it directly goes into the chamber B, and from the chamber B it goes to the chamber A. If the chamber B is in regeneration mode, first it will go to the chamber B and then the chamber A. If, for example, A is in the regeneration mode, then first it will go into the A and then to the B. So this regeneration process is done for 2.5 hours. After that, it is stopped for 1.5 hours for cooling. So it is used by the compressed air only, and that is after generation of the compressed air before dryer. So it is the most economical method of air drying. Membrane dryer. Membrane dryer is by the selective permeation of the gas component in the air. The dryer is a cylinder type with tiny holes or hollow polymer fiber with an inner coating. These fibers have a selective permeation for the removal of water vapor, and the permeated water is vented into the atmosphere outside of the cylinder. This permeation is caused by the difference of the pressure of the gas, both inside and outside of the hollow fiber. See, here also no heater is used, no compressed air is used. But why still the membrane dryer is not used? Because the membrane itself is very expensive. So, as per the Indian standard, what should be the capacity of the air receiver tank used in the compressor? Why the air receiver tank is used? Air receiver tank is just like a storage tank which keeps the air stored for the change in the requirement or the change in the pressure for some time to maintain the air requirement. So, according to the IS standard 7938196, the volume of the air receiver should be 1 by 10 or 1 by 6 of the output in meter cube per minute. This is very simple, though it is related to the topic, so I have discussed it here. The volume of the air changes if there is any changes in the pressure or temperature or both. So P1 is into V1 into T1 is equal to P2 into V2 into T2. While you are doing the commissioning of a compressor, then the conveying air line should also be taken in care, because with the change in the diameter, the area of the pipeline, there will be change in the pressure and the flow. So let us calculate how we can calculate the diameter of a pipe. For example, the capacity of the compressor is 200 CFM. Working pressure is 7 kg per centimeter square. that is P2. Required velocity of the air is 6 meter per second. Atmospheric air pressure is 1.013 kg per centimeter square. So what will be the V2? V2 will be P1 into V1 by P2, which is equal to 0.01365 meter cube per second. You will calculate that. Now, quantity of the airflow will be what? Area of the pipeline into velocity of the airflow. So, quantity of the airflow is 0.01365 meter cube per second, which is equal to the area multiplied by the velocity of the airflow. So from here it comes the diameter of the pipe is 0.0538 meter, that is approximately equal to 2.11 inches. So the diameter of the pipe should be 2 inches. That is how you can calculate the diameter of the pipe. What is FAD? Free air delivery. If the deviation in the FAD means free air delivery of the compressor is more than 10%, means if it is of 200 CFM capacity and it is giving the output of less than 180 CFM, then it is a matter of concern. We should take the corrective action. But how will you calculate the free air delivery? So, to calculate, first we will take some data as the reference, which is given by the manufacturer. So, they will provide you the initial data. The piston displacement 16.88 meter cube per minute. For example, compressor capacity is 15 meter cube per minute at the rate of 7 kg pressure. Its rated RPM is 750. Motor rated RPM is 1445. Receiver volume is 7.9 meter cube, while oh, the holder volume is 0.4974 meter cube. So total volume is 7.9 plus 0.4974 is equal to 8.287 meter cube. Now let us consider that the initial pressure is zero point 0.5 kg per centimeter square and the final pressure is 7.03 kg per centimeter square. Atmospheric pressure is 1.026 kg per centimeter square. Now we'll have to take the time taken to build the pressure from initial to the final. It is 5.2 minutes. So the compressor output is equal to P2 minus P1 into total volume by atmospheric pressure into pump up time is equal to, this is 7.03 minus, if you will calculate it will come as 10.14. That is the compressor output. So what the output is given by the manufacturer is 15 meter cube per minute, but your output is 10.14, which is approximately 32% less. Then it is a matter of concern and it need to be checked and done the maintenance. Thank you. Please like, share, and subscribe for such videos related to the electrical engineering and efficiency of the plant. Thank you. Take care.